ready?
Yes, if I am, yes.
Okay. And so our first talk will be from Dimitrios Nikolakis from the Office of National Statistics. He will be speaking on the processing breaks in seasonality and time series.
Hello, can I start?
Yes, please.
Thank you. The topic is about handling seasonal breaks in monthly or quarterly series using WinX13, but I will talk in general about seasonal adjustment as well. I will start, I will minimize that. I will start with seasonal adjustment diagnostics criteria, say that I am between to add, I will put camera as well, to add one additive outlier or not, what are the criteria based on diagnostics? How can we make decisions based on SI ratios and overlay graphs? Then I will show how to introduce a seasonal break. Initially, I will show how to introduce a seasonal to non-seasonal break and then a double seasonal break. And at the end, I will do a thorough demonstration in X13, okay, depending on the time, where I need to change the data point of the seasonal break. Initially, just I show you some screenshots from diagnostics in X13. As I say, the series are some series that we processed in ONS, but the names are with code, so it's not something that you will understand, but the goal is to show you the process. Okay, as other people have talked yesterday, the potential colors are three. White means that the spec file doesn't produce any warning at all. Yellow, that we have a small number of minor warnings, like to have an insignificant regressor. And the pink means that the spec file produces large warning, for example, visual trading TBX. And where there are errors, X13 doesn't run at all. Of course, we prefer white color. Then if we are between yellow and red, we prefer the yellow. As you can see, I will show you one example here. Here are some regressors with, these are the t-values in the brackets. This is a trading day effect with a p-value. In general, we prefer to have t-values in absolute terms higher or equal to 3 and p-values 0. This is the ideal, but at least acceptable is when the t-values are between 1.96 and the p-values between 0.01 and 0.05. And not acceptable is when we have t-values lower than 1.96 or p-values higher than 0.05. Of course, both t-values and p-values depend on the length of the series. We take into account some model diagnostics. For example, here this is the forecasting error the last 3 years. We prefer this to be as small as possible. I mean that if I add an additive outlier and it will be 9, I will prefer the second option. Now here, this shows if the residuals pass normality test. Here, ideally, we would like to have OK. All the other are potential options, potential results. There are 2 columns that ideally we would like to have a 0 number. All the interpretations that I wrote you can find from here. I didn't write anything special. Here we have 0. Those columns here, we would like to be empty, or as for example, this column SIG LBQ shows the list of flags with significant LBQ. And we have some columns in spectrum and QS that also would like to be empty. Here I forgot to tell that if it's not possible to have 0, we prefer to have a small number like 1 or 2. Here you can see the interpretation. I can send the presentation at the end. There are some columns that have p-values that they are between 0 and 1. We would like to be at least higher than 0.05, but the higher the better. If any of those p-values that I will show is below 0.05, there is an indication of residual seasonality, especially if they are 0.01, we have a serious problem. Like this. This is the D11F and the D11F last 3 years. In this example, we don't have residual seasonality. Those two can be indicators of residual seasonality if the p-values are lower than 0.05, or all those numbers here, they are p-values. In this example, they are 1. Here you can find all the interpretations from help. There are also some, those 2 columns we prefer to be empty, or at least the number in the bracket to be 3 or smaller. For example, this here non-sig seasonal peak shows whether there is a non-significant peak at any of the S1, S2, S3, S4 in the spectrum of the seasonally adjusted series, and gives the heights in stars of the tallest of these peaks. Now let's talk about M1 to M11. This can be found here. Those values can take values between 0 and 3. And when the value is higher than 1, it indicates a potential problem. Now let's talk about the indicators of seasonality. Indicator of seasonality here is M7, and which is just an average. It shows the amount of moving seasonality present relative to the amount of stable seasonality. There is also the out file that we have identifiable seasonality test and moving seasonality test. Now, we seasonally adjust when M7 is lower than 0.8. Here, there is not any absolute rule. This is just the experience. When identifiable seasonality present and there is not any evidence of moving seasonality at 5% level, we don't seasonally adjust when M7 is higher than 1.2. When identifiable seasonality not present, or when there is not any evidence of moving seasonality at 5% level. Okay, say that I have an M7, say 1.3. In order to be sure, just I try various spans to see the M7, to see if there is any M7 that is seasonal when I suspect that the series is non-seasonal, but I'm not sure. It doesn't mean that just I see M7 1.3 and I say, okay, it's non-seasonal, and I ignore everything. This is just for your reference. And when M7 is in the gray area between 0.8 and 1.2, we investigate potential breaks. And or when identifiable seasonality probably not present, and when moving seasonality present at 1 or 5% level. I mean, this, when we are in this category, it's more possible to have a seasonal break, and we make more thorough search. Now, let's talk about decisions based on SI ratios. When there is a data point, that is far from the others, far from the horizontal lines, this is a potential additive outlier. Here, for example, 2018 Q2 is a potentially significant additive outlier that we have to test. Here, as you can see in Q4, the last dots are above the horizontal lines except of one, And the first data point is 2015 quarter 4, so this is a potentially significant seasonal break. Similar for 2016. From 2016 and onwards in Q1, all the data points or the dots are below the horizontal line. Here let's talk about overlay graphs. Here in 2012, we have a potential significant level shift. Here the blue line and pink line, when we have the level shift, should be as close as possible, those two lines. And 2022 quarter 4 is a potential significant additive outlier, and if we put that in the is significant, the pink line will be horizontal at the end. Here is something that it's fictional, it's not any official data. Here, until 2007 quarter 1, we have a horizontal line, so, and after it seems that the series are seasonal, so 2007 quarter 1 is a point to put a non-seasonal to seasonal break. Now let's talk about how to introduce a seasonal break. Let's talk, here I have two examples. Let's assume that based on SI ratios, 2012 quarter 2 is a potential data point for a break. Okay, I put default transformation, default ARIMA model, and I test this seasonal break here in regression. If initially I get a non-seasonal ARIMA model, non-seasonal, it means that I have only one bracket, like here 1, 1, 0. I add a seasonal part, 0, 1, 1. And here, as you can see, the seasonal break is significant. The p-value is 0.01, so we can continue. Now, how to decide the type of seasonal break? I test using all the default options, M7 before and after the break. Here, before the break, M7 is lower than 1, after the break, much higher than 1. So the most reasonable option is to try a seasonal to non-seasonal break. I put a model span and everything else default transform, default ARIMA model, test Easter and trading day effects and outliers. Here we have a log transformation. The ARIMA model is something acceptable, is the airline model, so all good. The D10 file, I copy paste into a spreadsheet and I change D10 to PPP. After the point of the break, which is 201, 201, you know, it's 2012 quarter 1, I put ones. If I would have no transformation, I would put zeros here. And in order to avoid future errors, we extend at least 2 years with ones. Then the updated Excel columns we copy paste to Notepad and save with the name of the series, and we put PPP extension, the same location with the spec file and that file. This is the final spec file. I run that. Here, as you can see, until 2012 quarter 4, the series is seasonally adjusted, and then you can see only the gray line. It's non-seasonally adjusted. It may not be the best example because a perfect break means that seasonal to non-seasonal, that all the horizontal lines should be at similar level. But I have tested that, and after M7, all the spans are non-seasonal. The M7s are higher than 1. Now let's talk about a double seasonal break. Say that I found 2 data points, 2012 quarter 4, 2020 quarter 1, that are potential data points for a break. There is a distance between those 2 points, 5 years, higher than high years. So I can put both. I can put a double seasonal break. Say that I test initially 2012 quarter 4. I found the constant. For this reason, I put in the second 0, I put 1. I mean, instead of ARIMA 200,011 to 100,011, and the other default transformation. And as you can see, the yellow box, I get a p-value of 0, significant. Then I do similar things, similar process for 2020 Q1, again significant. So it works to try the seasonal break. To decide, I test M7 with all the default options before the first, between the two breaks, and after the second break. Now, so I know that you will ask me, okay, the last data point, the last break is 2020, but if I put span 2020 Q1, X13 will not run because it will be 3 years, and in order to be 5 years, to see if the M7 is very, very high, I test that to see if the M7 is below 1.
You have 5 minutes.
Thank you. Okay, as you can see, all M7s are below 1, but this is also can be found from the graph. Here I put the RMX in a notepad. I copy paste the columns. Initially I put that in the latest break because it's easier. As you can see, 2020 Q1. I copy paste the columns first, second, third, and I put a II. The first 3 columns after the date is the last seasonal break, and we put zeros from 2020 Q1 and onwards. The other are the early break. We put again zeros after the break. And I extend in similar way with zeros at least 2 years. I have extended until 2028 Q4, okay. Then the updated notepad I copy into Excel. No, I copy to RMX. I update the RMX. I put all default options here. I run. You can see here that I put Q1, Q2, Q3, P1, P2, P3 because it's a double break. You can see here that the vertical lines cross the horizontal line, which means that the break is successful. And now I will do a demonstration of an example in X13 that there is a change in the data point of seasonal break. At least I will try to do the best. Okay, here there is nothing obvious in overlay graph. Personally, I don't like so much Q1 because the vertical line doesn't cross the horizontal, and I don't like in Q3. Okay, everything else is acceptable. I tried default options, everything default. And here, based on that, I thought to test 1999 Q2 and 1999 Q4. No, I have tested, sorry. 2000 Q2, 1999 Q4. I have tested 2 data points for breaks. Now to decide the type of break, say that I ran that. I got error message and I tried with 011 with the airline model. Okay, before the break M7 is like that, is much lower than 1. I'm sorry.
You have 1 minute left.
Thank you. After the break again is lower than 1. So we can put a seasonal to seasonal break in 1999 quarter four. Here I put the break with all the default options. Okay, initially it is red. Then I made some manipulation, and this is the final manipulation of outliers. Now let's see the final. Okay, here you can see that the vertical lines are better. For Q3, it crossing the horizontal line seems a little bit better. And I have put two additive outliers. Here the color is yellow. Here we have improved the forecasting error, and the failed I made okay, which is good. I don't have any residual seasonality. Now you will ask me why I tried 1999 quarter four and not 2000 quarter two. Okay, I thought that this is a natural question. When I'm between two data points for a seasonal break, I compare the p-values, and when the p-values are the same, say that I have zero p-value for the two options, I compare the forecasting error in order to, okay, then I will say I will select this with lowest forecasting error and zero p-value, because I'm sure that you would ask me. That's my presentation. Thank you.
Okay, thank you, Dimitrios. In the interest of time, we'll delay any questions until after the next talk. Speaking of that, our second talk will be from Dimitrios.